Okay, to our warm-up, just a reminder of the transformations that we did yesterday was all addition and subtraction. And we just had to pay attention to, did that addition or subtraction happen on the inside, or did it happen on the outside of our function? And then we consulted that whole Ilroud thing to know which direction it was moving us. So as we look at this first function, now this is not one of our parent functions, so we would not go to our table of favorite points and set that up and impact our table or anything like that. We're just going to utilize the 5 points that they have in this picture and do these things to them. So the first subtract one in this one is inside, and inside subtraction says I'm going to be moving my graph right 1. The second subtraction we see in this one is outside of our function, and outside of our function says we are going to be moving our graph down 1. Now that's not two different problems. That's just two movements that I would do to each dot. So then I would come up here and I would take each dot and I would move it right 1 and down 1 and put my dot for my final graph. Move it, that's not right. Let's try that again. Right 1, down 1. Right 1, down 1. Right 1, down 1, right 1, down 1, and right 1, down 1. And then it's just to connect the dots picture. And that would be my graph moved to the right 1 and down 1. Questions? Same thing on this other one. Each of these, now these all change to addition. Inside addition says move left. Outside addition says move up. I would take each dot and move left 1, up 1. Left 1, up 1, all the way across my picture. And then once I get all those moved, I connect the dots. Questions? This is definitely something that you're going to see show up on your DCA on Monday, is that they will give you things that are not parent functions. They will ask you to either describe the transformation that happened or to pick the graph that would have that correct transformation, but your DCA on Monday is multiple choice. Fast forward to the end of the chapter, you will be asked to finally graph these by hand. So you'll kind of see it both ways. But as you prepare for Monday, you're thinking more correctly using words to describe things, being able to match pictures. You won't be necessarily responsible for creating your table, so you don't have to have like those parent function tables memorized by Monday. By the end of the chapter, we'll want to know those. Okay? All right. With that being said, we are learning the rest of our transformations today. I did give you guys a note sheet, and you'll also want your cheat sheet out because we're going to go back to that a couple times as well. The last transformations that we have to add, which will cover everything, will be reflections and then shrinking and stretching our graphs. And again, those can happen vertically and horizontally in everything that we do. Reflections is kind of the last time that looking at it on a calculator can be pretty obvious as to what's happening. Again, you guys will never graph these on a calculator, but I did this just to show you that I took the parent function, f of x equals the square root of x, which is the blue one, and I put a negative in front, and in front would be considered outside of our function, right? And see what happened where that ended up in the red, and you can see that it looks like it flipped over this line right here, this line being our x-axis. And then we've got this picture in the green, where I moved the negative to the inside of the function, and from the blue to the green, it looks like it flipped it vertically, not vertically, horizontally, across what is our y-axis, and that's exactly what happens. This is a very basic watered down just reflections part. That's exactly what happens. And so reflections are this. Again, they come from a negative, not subtraction, but a negative in our function. If that negative is located on the inside, it will reflect over our y-axis. And we will abbreviate that as ROY. You don't ever have to write out reflection over the y. If that negative is outside of our function, it will reflect our graph over the x-axis. We will abbreviate that ROX. You are also welcome to refer to them as like Rox and Roy. We're going to go next to our cheat sheet and describe these on our cheat sheet. Okay? So the first thing I would do is remind myself what kind of thing in my equation that I'm looking for this reflection thing to happen. And that would be if I have a negative in my equation. And all negatives will be addressed by doing this. If that negative is outside my function, that is referred to as an ROX. But what I'm going to talk about here and then in our next type of transformations is super important. This is your function notation for outside of your function. The more you can understand that anything outside of our function when we go to our table will impact our y column. Always. It doesn't matter if it's a negative, a multiplication by a number, a plus or minus. It all impacts our graph vertically, which is your y column. So what will I do when I see a negative on the outside of my function? I will go change every sign in the y column. Now, I do want to show you, because it does bother some people that we call it an ROX, a reflection over the x-axis, but I'm telling you to go change the signs on your y column. And why are those two letters not matching with each other? So I just want to show you a very basic example here. If I were to look at the point over 1, up 1, which would be at 1, 1, if I were to reflect that over my x-axis, here's your x-axis, right? And I reflect it over my x-axis, that means I would count how far away I am, which is 1. I would go that same distance on the other side and regraph my point, and it would end up here at 1, -1. Notice your x value stays the same, but as I reflect it over that x-axis, my y is what changed, and that's why we go to our y column and change all the signs. It doesn't matter which direction you're reflecting, it would change from positive to negative or negative to positive. Okay. Same thing on our y-axis reflection, or an ROY. This would come from a negative on the inside of our function. The generic function notation for that would look like this, f of negative directly on the x. That means then on my table, anything inside, and again, this statement right here, the more you can understand that, anything inside impacts your x column. Inside impacts your x column. Is I would go change every sign in the x column. Inside changes our x column, outside changes our y column, always. Doesn't matter what it is, reflections, later multiplications, that rule will always stand true. Any questions for me so far? Okay, so let's go ahead and try one of these. It says use the graph of f of x equals the absolute value of x to obtain the graph of g of x. And then they tell us that g of x is going to be negative absolute value of x. Remember, and this is the last time I'm going to write out our steps today, but remember our first step is to ignore the transform graph and just write the table for the parent function. Write the table for the parent function. In this example, our parent function, as listed in the directions, is the absolute value of x. So if I go to my cheat sheet and find the table for that, I'm going to use the extended table here, or I just plug these numbers back into the function. I don't have to have it memorized. It's just taking the absolute value of every number that I plug in there. After I have gone and got that table, step 2 is now to apply my transformation. And eventually, that's going to end up being multiple transformations. We only have one transformation in this one, and that is that negative that is, wait, before I say it, is that negative inside or outside of our function? Outside. So we go back to our cheat sheet if it is outside, that is an ROX. Outside things impact my Y column. Okay, perfect. So one thing's first, you have to describe all of these things in words. You have to understand how to describe them in words. So first of all, that is called an ROX. Know that. Second, know what to do to your table, and that is to go down our Y column and change the sign on everything. Notice I did not change the sign on the 0. If I put a negative in front of 0, does it change it? No, negative 0 is 0. It's not actually a thing. So you don't have to put a negative on a 0 ever. If you did, it's not wrong, I guess, but I wouldn't do it. Okay. Now, guys, that is just your ordered pairs that you are now graphing. Go put those dots in your picture. -2, -2. -1, -1. 0, 0. 1, -1. 2, -2. Now, if I show you a picture of the original, which would have looked like this, you can see how the green flips over the X, ROX, axis to end up on the red. Questions? Okay, that's how you attack every negative. We take care of negatives first before moving on. You are going to try this one on your own. Use the graph of f of x equals the square root of x to graph g of x equaling the square root of negative x. We should have gone and gotten the favorite points for just the square root of x. Remember, this is one where we strategically picked what x is to plug in there because I don't want to like try to take the square root of a negative, which we can't do. I also don't want to take the square root of something I don't know the square root of. So the numbers I filled in here were all perfect squares to make my y numbers nice and pretty. Square root of 0, 0, 1 is 1, square root of 4 is 2, square root of 9 is 3. We run off our graph there pretty quickly. That I need to describe the one transformation going on. First of all, if it is inside, ROY, and inside things always impact our X column. So I'm going to come to my X column, I'm going to go down that column and change the sign on everything except for 0. Those are my new ordered pairs. I go graph them in my picture. -1, 1, -4, 2, -9, 3 runs off my graph. It'd be somewhere over there. Looks like that. If I compare that again to the original, which would have looked something like this, if I draw that quickly, you can see how that flipped over our y-axis. Any questions on how to attack reflections, negatives, when we go to graph? Our last type of transformation I did not show you a picture of because they're actually on your calculator, really challenging to see what is happening. And that is our type of transformation that will either shrink or stretch our graph. Now, it is very important that you understand that it is caused by some sort of multiplication. Multiplication. If that number that you are multiplying by is on the outside, and again, remember this will hold true for everything, that outside things will always impact our graph vertically, and vertically means our y column of our table. That inside things will impact our graph horizontally, always, and that is our x column of our table. And then we need to talk about that whole opposite word. If you remember like our ill route, Or when we were talking about adding or subtracting inside, a minus actually moved us to the right, and a plus actually moved us to the left, which again is opposite of what we think it should, because inside things are always opposite. Now, we are talking multiplication, and the opposite of multiplication is division, right? Now, what does that actually look like? It looks like multiplying by the opposite, or we turn the number upside down, the reciprocal of the number you see in your function. This can be slightly confusing because we just came off of a time when we were talking about parallel and perpendicular lines, and in perpendicular lines it had two words, including reciprocal, opposite reciprocal, but we are not doing the opposite reciprocal. We're not changing the sign on it. It will be the same sign as whatever's there, which will actually be positive at this point, because if it was negative, we would have taken care of that in our reflection box, okay? So if the number is a 3, we would multiply by a 1/3. If the number was 1/3, we would multiply by 3. You just turn it upside down. Just reciprocal it. Okay, we are going to go to our cheat sheet next, if you are ready. Again, very important that you understand that this is going to happen because of a multiplication, that if there was a negative number, the negative part of it would have been taken care of in the box above that said reflections. We are now dealing with just positive numbers that are multiplying our function. If that number happens on the outside of our function, it will impact our graph vertically. In generic function notation, that would look like some number multiplying on the outside of our function. What do I then do is I go to my table, I take that number, anything outside will always impact my y column. Important that we know how to correctly describe these transformations in words. So, if that number is something bigger than 1, big number, we will describe it as a vertical because it's outside of our function. And then you'll use the same pattern every time. Because this is a big number, we would describe things that are big numbers as a stretch by whatever that big number is. If that number happens to be a fraction, and the way that we can mathematically show that over here would be like 0 is less than our number is less than 1. That means it's a fraction. It's still vertical because it's outside of our function. But if we ever are multiplying by a small number, a fraction, it's going to end up shrinking our graph. So we would use the word shrink by whatever number we multiplied by. Here's what you need to understand. Two very important things that will make this a lot easier. This will be a good time to stop here in just a second. This number right here, whatever number you put in your description, will always be the number you multiply the table by. If you remember that rule, and then this rule, that these need to match. What do I mean by these need to match? If I use the word stretch, it needs to be followed by a big number. If I use the word shrink, it needs to be followed by a fraction. I will never say shrink by 10. That doesn't make sense. So those words, whether you are talking vertical or horizontal, it does not matter. Those words will always match the number that follows it. And the number that follows it will always be what you multiply your table by. Okay, we will pick back up with this side when we get back from lunch.